So this video is on request of students who wanted to understand the difference between mutually exclusive events versus the independent events, statistically independent events. Mutually exclusive, as the name suggests, is as simple as that all sets are disjoint sets, and hence occurrence of one particular event rules out the occurrence of all other events. We say in terms of probability in set theory, probability of A1 union A2 union A3, as in suppose there are n events an, should be equal to probability of A1 plus probability of A2 and probability of an. Since they are disjoint, so the total set of elements in union is same as the total sum of individual elements. So this basically is mutually exclusive events, whereas in statistically independent events have a different understanding altogether and often are confused with mutually exclusive. Let me take a Venn diagram and explain it to you how it works for independent events. So what I do is I take basically two sets. We will begin with two to understand and then get back to 3, 4 in a general term. And maybe if I call them events A and B and assume there are certain elements here and their count is say X, there are certain elements here and maybe their count as y, some elements in the intersection z, which could have been phi if it was a mutually exclusive events, and there are certain elements maybe w which are neither in A nor in B. I call this as my sample space S. Now what do we say as independent events or statistically independent events? They say that occurrence of one particular event doesn't affect the occurrence of other event, which would mean probability of occurrence of A given that B has already occurred is same as probability of A. At the same time, probability of occurrence of A given that B has not occurred is same as probability of A. That means the occurrence or the happening of event A is irrespective of happening of B or not happening of B. For this to happen, we need to just work on this. We have already seen what is conditional probability. So looking into that, or maybe at this moment we ignore that and simply go to the Venn diagram and then come back to the formula. So probability, first I'll take this particular case, probability of A by B. Given that B has already occurred, what is the probability that A will occur? So the answer is X upon X plus Z. X upon Z upon Y plus Z. Y plus Z is from where B will occur, and given that B has already occurred, if A also occurs as coming through Z, should be same as probability of occurrence of A. That means X plus Z are the total number of elements in A upon X plus Z plus Y plus W. You cross multiply these and simplify them, you will come to know that this gives you a result W into Z is equal to X into Y. Remember, elements which are neither in A nor in B multiplied by elements which are number of elements which are both in A into B should be same as the product of number of elements which are in A but not in B multiplied by as in product of elements which are B not in A. But ideally, when this happens, this should automatically happen because you cannot put both the conditions. So when we look into this, what is the probability of occurrence of A given that B has not occurred? So if B has not occurred, so that means it is not coming through these elements which are counted as Y and Z. So that means the correct answer of occurrence of A when B has not occurred, the probability would be X upon X plus W, and this should be equal to X plus Z upon X plus Z plus Y plus W, which you simplify, you will come to know is same as because if you can look at it orally also, x square gets cancelled with x square and xz cancels with xz, wx cancels with wx, so remaining is xy is equal to wz. So that means these two, one of them suffices for the other, and this basically is called as mutually exclusive events. No, this basically is called as statistically independence of event, which in general would mean that probability of A into probability of B is nothing but probability of A intersection B. Try to recall with the formula of probability of A by B. You can understand the same thing by going otherwise. Probability of B given that A has occurred should be equal to probability of B. So ultimately we lead to this result that two events are said to be statistically independent if probability of A into probability of B is same as probability of A intersection B. This becomes the case of number of elements, so to say. Had there been more than two elements, maybe say n such elements, then we need to look into that how does this look like when they are statistically independent. So we say in such a case, probability of A1 intersection with A2 intersection with A3, that is simultaneously happening up to AK, let me call it K, should be same as probability of A1 given that probability of A2, given that A1 has already occurred, into probability of A3 given that A1 intersection A2 has already occurred, and so on, which if you apply the conditional probability formula, you will get that this is basically probability of A1 into probability of A2 into probability of A3, and so on up to probability of AK. So that means the product of individual probabilities, if is equal to the product of their intersection all taken together, then these probabilities, these events are basically called as independent events. When you apply this formula here, so you will find that they basically one and all cancel accordingly and you result into this thing. Now coming to that particular JEE question, which has given a thought that how this should be dealt with in terms of problem. So I'll take that problem and very quickly we'll come to that. So if I look into that problem, yeah, this as such is not required. Yeah. So they say, just run through the problem and then I'll explain. Yeah. So X be the number of elements in a particular set, and we have 1, 2, 3, 4, 5, 6 elements be the sample space. If A and B are two independent events, this is the crux of the question, that they already called it independent associated with this, then the number of ordered pairs A, B, that means in how many ways can you find two sets A and B out of this, such that the number of elements in B is less than the number of elements in A, both greater than or equal to 1. So you cannot have a 5 for any of these elements. What is this probability? Now, if I in general take it, we conclude to a different answer rather than calling it as a statistically independent. If we only deal with this much, that means we will take all such cases when the number of elements of A is bigger than the number of elements of B. But this is what we are not supposed to do. We need to first look into probability of A intersection B is equal to probability of A into probability of B, and then look into all possible such cases. So if I quickly look into the Venn diagram and say that there are certain elements in A, certain elements in B, and of course there are certain common elements, then in how many cases this happens. So the first case, it has to be done case wise. So the first case that we come across is that when we have 4 elements probably in A and 3 elements in B and 2 elements in common. somewhat like this. So the sixth element is here. Now if you look into this, 2 into 1 is 2 into 1, the way we dealt it other. So this basically, when you look at probability of A intersection B, you find it that this is basically 2 by 6. When you look at probability of A, that is basically 4 upon 6. And when you look at probability of B, then it is 1 upon 6. Can you see that are they both same or not? So if I cancel this, is this a correct case? The answer is definitely yes, because probability of B is not 1, probability of B is 3 by 6, so 12. And now for these cases, we need to find how many such cases are possible. Accordingly, the another case, then and so on. So this was a very good question of JE, which, ignoring this fact that A and B are independent events, would have given a different answer. Try such more questions. I'll come back again with these results.